What's up, boys and girls? New phone setup. It's a better Arduino setup now. Let me check where the. Yep, it's picking up the external microphone, which is good. So back to Arduino, right? I'm having Diet Coke after a while because I got a bit sick, right? Okay, Arc and Obsidian. Let me check if this thing is coming out to be fine. Okay, Arc and Obsidian. Yep, stream has started. It's been a while since my last Arduino stream. Let's see what we needed to do. Oh yeah, I need to understand the LED button diagram, right? This is other stuff. Arduino. Wait, it was super static kit, right? Yep. Blinking LED. No, yeah, controlling LED with the button. There we go. This was the diagram. And okay, before that, I have a bunch of cells that have like basically lost its charge, right? I want to try this ammeter thing on it. I mean this multimeter thing on it. And like last time I think I figured out how to use it. Pretty sure that's what the entire last stream was. Look at these cells. Look at these cool little cells. They were in my alarm clock, which I use in my bathroom. But yeah, they're out now. They're supposed to give you 1.5 volts, but let's see what they're actually giving. I must have a note about this multimeter too, right? Yep. Pulsevo multimeter, measure voltage in the proper range. If you get one reading is outside current range. Interesting. Measuring large amounts of current up to 10 amps. Oh yeah, this continuity check thing was cool. You know what, I should probably lock. Okay, this is locked, that's good. Cool. So we need to take the tip off. Interesting usage of words. So this kind of sacrifices my, my face view for the view of the actual thing that's going on, which is fine. I don't mind that. Plus I get to see my laptop screen properly from here, so that's nice. I shampooed my hair today. They're not looking the best, but that is okay. My dermat gave me an anti-dandruff shampoo because I have too much acne on my back apparently due to dandruff. Okay, how do you turn this on? It should be in the 2's range, right? So it's supposed to give me 1.5 volts, but if you can see here, it's giving me something like 1 volt. Okay, so it's not degraded that much. I mean, I don't know. This one is also giving similar voltage. Interesting. Yeah, that's just something I wanted to measure once. I wonder if I should like make my hands window bigger like this, right? And then I should have my notes here, my hands. How do I even set this up? Needs to be set half and half, right? Nah, that'll just make both of them small. What if I cut the side of the note? That doesn't seem like a good option. Fuck it, I'll just keep it how it was. Guess that was the best way I could do it. Maybe this can be a bit bigger and this can be a little smaller. And then there's my face. Yep. Looks okay. What if I put my face here? That looks okay too. Then I put this here. I think I like that more. But that's not symmetric. This is more symmetric. I'll just go with this. There's two squares that are doing nothing there, but fine. Anyway, let's turn a nice little multimeter off. Say bye bye to the cells. I won't be using them again. And what I need to understand is this circuit diagram, right? So from what I understood about the breadboard last time was that, yeah, this diagram. So all of these lines are connected. All of these lines are connected. And then these are connected kind of, you know, vertically, if that makes sense. So we'll be using a button, okay, and buttons are a component, blah blah, button jitter is a thing, I remember that. We'll be using hardware interrupt to help the button talk to the Arduino, that is to remove the jitter, right? to the processor by external hardware devices like keyboard to request this service can modify the process. Are hardware interrupts not related to button jitters? Interesting. Yep, they're not. God damn it, I fucking love Obsidian. I cannot say that. The more I say that, the more like I cannot say that enough. Interesting. I think I should have this open here. Chat is absolutely gone. That's okay. I'll be looking at these videos when I'm old. That is the true audience. Okay. So we have some Arduino functions: attach, interrupt, digital read, and delay microseconds. Spin. What is happening? So there's no mode for calling it when it's high. Interesting. Most Arduino boards have 2 interrupts. Welcome back, handy Arduino. After a while, it's been a while. Where is the connection wire? I lose that guy every single time. There we go. Let's go. So here's the Arduino. Digital pin 1 and 0 Tx and Rx is what is there, fine. Delay and millis. Okay, these also use ISRs, but this one does not, so that's why we're using delay millisecond, microsecond there. This is the program for amount of time. Suppose currently largest value to produce. Delay is 6 for delay longer than use delay. Reads value from a pin. Cool. Okay, finally time to understand the diagram. We have the Arduino pin number I'll just look it up from there. Why are we all the way up here? We were done with this, we were somewhere here, right? Yeah. So with the 5-volt pin, we're connecting the power line. Which side of the power line is this supposed to be? That's supposed to be the positive side usually, and in conventional current things flow from positive to negative, which is still extremely interesting, because I don't know why it has to be like that. We have the Arduino being powered from the positive side. Yep, that's the power going into this thing from the positive side. Then we have this thing going here and going up here, and we have a resistor in series, and then it goes up to this thing which I have no idea about. Okay, this is like a connector, right? And then it comes back. What is the point? Bro does not it's GPT time. I think I GPT'd this before too, right? Explain this diagram, please, please. Thank God for LLMs. Explain this diagram, please. Simple Arduino, of course, based push button LED control circuit. The microcontroller, okay. That's the button. Fine, fine. Okay, I forgot that was the button. We have the button. It comes here, then it goes from here into the resistor. We have two resistors for whatever reason. Into the LED that goes to ground. Okay, they have a good grounding setup here. Why did we used to ground stuff again? I saw a pretty good explanation of that, but I didn't of course I didn't add it in the Obsidian. Oh yeah, we'll get some good diagrams here, right? So So if we have whatever the fuck that's happening here, okay, that's not a good diagram because I do not understand it. We have a hot line and a neutral line. We have a ground conductor. That is also not a good diagram because I do not understand it. Okay, that's ungrounded because, yep, but in this case that's grounded, right? Yeah, grounding electrode system, it needs to be connected to that. In that case, why won't it always just go there? I wish you could open more than one GPT windows here, but fine. Completely going on a tangent here. What the fuck is that recommendation? Destroy insecurity with the simple Navy SEAL technique. Yeah, you bet I'm gonna say that to my watch later. That guy usually talks about jujutsu, but like he has some random videos too, and I watch all of them. What you gonna do about it?
Now, we are just covering the theory in this video, but remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. This wire is an emergency path to try and save you from an electric shock. Ideally, the ground wire in the circuit will never be used, but should a ground fault occur, then the wire is on standby, ready to take over. Under normal operating conditions, the electricity will flow into your home through the service panel and circuit breaker and then into the hot terminal of the receptacle. If we plug something in, then it could make its way over to the neutral wire and then out through the neutral incomer and over into the transformer outside the property. Again, I'm just animating the flow of electrons in one direction for outside the property. Again, I'm just animating the flow of electrons in one direction for simplicity. In the event of a ground fault, which is where the electricity took an unexpected route back to the source instead of passing through an electrical device, for example, the hot wire came into direct contact with a metal casing, then the electricity will flow through the metal body and into the connected ground wire, where it will continue over and then either pass through the neutral or a separated ground bus bar and then up through the neutral wire and over to the transformer. As this occurs, the current in the circuit is going to increase dramatically and almost instantly. In most cases, the sudden and large rise in current is detected by the circuit breaker, which will trip to cut the power to the individual circuit. The electricity will continue to flow into the building and into the other circuits on the service panel. The fault will then need to be corrected and the circuit breaker flipped again. We've covered ground, hot and neutral wires and faults in great detail in our previous tutorial. Links down below for that.
In this video,
the hot wires carry the electrical current from the supply and over to the load, and the neutral wires carry the electrical current from the load and back to the supply. The hot wires carry the electrical current from the supply and over to the load, and the neutral wires carry the electrical current from the load and back to the supply. So what does the ground wire do? The ground wire, under normal operating conditions, will not carry any electrical current. This wire will only carry electrical current in the event of a ground fault. Hopefully, this wire will otherwise never ever be used at all in its entire life. It's just there for an emergency path for the electricity to get back to the power source instead of it passing through you. The ground wire in most cases is a bare copper wire. It's uninsulated, but in some cases it is covered with a green insulation. This wire provides a very low resistance path directly back to the source, so electricity will prefer to travel along it because it's easier and can get back quicker. Connected to the main panel, we will find a thick copper wire which leads out to a ground rod. The ground rod is buried into the ground outside near the property. This rod is not used for ground faults. Its purpose is to dissipate static electricity and external high voltages like lightning strikes. There is also a ground rod connected to the neutral at the transformer. Many people think that during a ground fault, electricity flows through their ground rod and into the earth. But remember, electricity tries to get back to its source. It doesn't just go into the earth. And as there is a ground rod at the transformer, then there is a potential path for the electricity to get back to the source. But this path will have a very high resistance or impedance. And as we know, electricity will take preference over the path with the least resistance. So as we already have a very low resistance ground wire, which provides a path directly back to the source, the ground fault is going to take this route instead. The electricity flows through the hot wire and into the light and then back through the neutral. But if the hot touches the metal casing, then it will instead flow through the ground wire, back to the panel, through the bus bar, and then back to the transformer via the neutral wire. The ground wire has a very low resistance, so it causes a huge and instantaneous increase in current, which will trip the breaker. We therefore connect the ground wires to anything that could potentially become a potential path for electricity to leave its circuit, such as the metal pipes, the metal plates on the light switches and the outlets of their boxes. We also need to run one to the outlets because often our appliances are made of metal or they're covered with a metal casing, things like washing machines and microwaves. When you look at a receptacle and plug, you'll see that there is a hot turn washing machine because often our appliances are made of metal or they're covered with a metal casing, things like washing machines and microwaves. When you look at a receptacle and plug, you'll see that there is a hot terminal, a neutral terminal and a ground terminal. The casing of something like a washing machine is connected to a ground wire in the lead, which goes to the plug, through the receptacle and back to the panel to save you from an electric shock. Now, let's say you're outside with no shoes on and the ground or the soil is moist. If you touch a hot wire, you could complete the circuit and the current may pass through you to get back to the supply. In this case, the resistance is going to be very high, so the current might not be high enough to automatically flip the breaker and cut the power. This will likely lead to the person's death. Okay guys, that's it for this video, but to continue your learning, then click on one of the videos. A hot wire, you could complete the circuit and the current may pass through you to get back to the supply. In this case, the resistance is going to be there to save you from an electric shock. Now, let's say you're outside with no shoes on and the ground or the soil is moist. If you touch a hot wire, you could complete the circuit and the current may pass through you to get back to the supply. Hot wire, you could complete the circuit and the current may pass through you to get back to the supply. In this case, the resistance is going to be very high, so the current might not be high enough to automatically flip the breaker and cut the power. This will likely lead to the person's death. Okay guys, that's it for this video, but to continue your learning, then click on
Won't say I understand it completely, but fine. So anyway, this grounds it so that I guess if I touch anything here, the current won't flow through me. Okay. Where's this ground going? Okay, this is what I was looking for. It's Okay. So in a way, if the ground air is connected to the negative terminal, that means it's the place where electrons won't go, and electrons will run away from to the other side.
क्या कर रहा है?
स्ट्रीम कर रहा हूँ अभी नहीं.
काम कर रहा
हाँ.
अभी तो रोल ही खा रहा है ना.
बंद करो गेट. क्या हुआ?
तू रोल ही खा रहा है ना.
रोल का खा रहा हूँ मैं. भिंडी खा रहा हूँ.
भाई चिकन और रोल खा रहा था.
नहीं, मैं भिंडी को ज़्यादा कर
है?
रहा
काम कर रहा है?
हूँ. हाँ, कर रहा हूँ मैं.
नहीं पूछा था कि वो पूरा एनर्जी कॉल कब करेंगे? बाद में करेंगे?
बाद में. I feel like listening to some LOTR background themes. Why is my Mac lagging? Okay, cool. We have a ground so that if the current doesn't take the actual path, it can take this path. It makes no sense, but okay. Isn't it connected to 11? They do share the common ground connections. What is encoding overloaded?